into the field of view, and Norishige Kanai, the Japanese astronaut who has been supervising all of the work today. Scott Tinney into the field of view, and Norishige Kanai, the Japanese astronaut who has been supervising all of the work today. Scott Tinney into the field of view, and Norishige Kanai, the Japanese astronaut who has been supervising all of the work today. Scott Tinney into the field of view. Line heaters that will remove two flex hoses from a radiator beam valve module on the truss of the International Space Station, and he will also be in charge of most of the work associated with the removal and replacement of that camera assembly out on the port truss of the International Outpost. This is Mission Control Houston as we continue to watch spacewalk preparations unfold. Soon, the two spacewalkers, Drew Feustel and Ricky Arnold, will be assisted out of their current positions on the side walls of the equipment lock section of Quest through the hatchway into the crew lock section of the two-compartment Quest airlock to close the hatch and begin the depressurization of the crew lock of Quest that should get underway about 35 minutes or so from now. Again, if you're just joining us on NASA television and Facebook Live, the crew is running slightly behind schedule. It took longer than expected to complete leak checks to Drew Feustel's spacesuit earlier this morning, and so we're now expecting the start of today's spacewalk to occur shortly after 8 a.m. Central Time, 9 a.m. Eastern Time. We'll keep you posted on all of that. In the meantime, we're continuing to take questions that you're providing for us on social media at the hashtag AskNASA. The next one comes from Suda. He asks, what if an astronaut's harness breaks during a spacewalk and they start floating away from the International Space Station? Great question. You'll see soon that the assistants for today's spacewalkers, Norishige Kanai and Scott Tingle, will be outfitting Drew Feustel and Ricky Arnold with jet-powered backpacks called SAFERs, the acronym of which is Simplified Aid for EVA Rescue. Those are nitrogen-propelled maneuvering units, if you will, in the mold of the old man maneuvering units, but slightly smaller in design. In the highly unlikely event they would become untethered from a variety of tethers and other assisted aids that they have once they're outside on the structure of the International Space Station, they could propel themselves back into the safety of the truss of the station to make their way back to the airlock. So they have the ability to make their way back under the power of those Simplified Aid for EVA Rescue jet-powered backpacks in the unlikely event they would become untethered. The next question comes from Worthington Publish, who asks, what is the longest spacewalk in NASA history? That also would be the longest spacewalk in history, period. 8 hours and 56 minutes that occurred on March 11th, 2001, some 17 years ago, by Jim Voss and Susan Helms, on the STS-102 mission, a spacewalk of considerable length in which they laid out the cable configuration for the third in the series of pressurized mating adapters or docking ports on the modules of the International Space Station, and to install a cradle assembly for the Destiny laboratory of the International Space Station on the truss of the International Outpost. 8 hours, 56 minutes, that EVA, on March 11th, 2001. If you're interested, the next two longest spacewalks in history, 8 hours, 29 minutes. That was during the STS-49 mission, the maiden flight of the Space Shuttle Endeavour, to retrieve the wayward Intelsat communications satellite, May 13th, 1992. That was a three-man spacewalk, the only three-person spacewalk in history, by Pierre Thuot, Rick Heeb, and Tom Akers, to manually capture that Intelsat satellite. And apropos to one of the principals here in Mission Control today, that you'll be seeing and hearing from throughout the course of the spacewalk, the third longest spacewalk in history, 8 hours, 17 minutes, occurring on August 30th, 2012, during Expedition 32 by Sonny Williams and Aki Hoshide, who will be the ground IV or spacewalk communicator, talking directly to Feustel and Arnold when they're outside of the International Space Station today. They removed a faulty main bus switching unit and rigged cables for future Russian module arrivals as they worked in the void of space on August 30th, 2012. And there is a view of Aki Hoshide as he settles into his chair at the Capcom console. Next to him is Leslie Ringo, who will be talking to the crew members inside the International Space Station as required throughout the course of today's activities.
to report the time to the ground. Close the first valve down. Listen, airlock. Resume in-suit pre-release clock. 1 to 12:14.
Copy, 12:14.
Listen, airlock. Step 22 of the METOX replacement. 1 minute has been elapsed and both suits are leak tight. Successful leak check.
Copy, Nemo. Thanks for the report.
Listen, we are going back to pre-release protocol, step 13, and starting safer donning from now.
Copy, Nemo. We're following.
This is Mission Control Houston, a good view of the flight control room on the forward row, the flight director's console. In the white shirt is the flight director for today's activities, Tony Sakachi. Seated to his left on the right of your screen in the blue shirt is Flight Director Anthony Varia, who is sitting with Sakachi today and who will be the lead flight director for the next pair of spacewalks that are coming up a bit later this year in the spring. At the very left-hand side of your screen, Aki Hoshide, who will serve as the ground IV. You can see him on the left side of your screen. Veteran Japanese astronaut. Hoshide will be the spacewalk communicator, talking directly to Drew Feustel and Ricky Arnold as they're outside of the Quest airlock conducting their work. In the back row on the right side of your screen is Grant Slusser, who is the lead spacewalk officer for today's activities. He will be working directly with Flight Director Tony Sakachi and Hoshide to keep the crew on track and to talk to his back room and resolve any issues that may crop up during the course of today's planned 6.5-hour excursion. The next step for the crew in the equipment lock will be to be assisted in donning their simplified aid for EVA rescue backpacks, those jet-powered backpacks that would be used in the highly unlikely event the crew would become untethered during the course of today's activities. You can see the frame for one of the safers coming into the field of view as the suit IV or intravehicular crew member Norishige Kanai works the checklist and talks to the ground here in Houston. As we look at this picture, the International Space Station is flying 254 miles just to the east of the Falkland Islands over the South Atlantic, about to begin a southwest to northeasterly trajectory in an orbit inclined 51.6 degrees to either side of the equator. There is a good look at the end effector on the space station's Canadian-built robotic arm, the Canadarm2. Ricky Arnold will be riding that arm and a portable foot restraint for some of the work that he'll be conducting outside. That will include the disconnection of flex hoses on a radiator beam valve module that were identified as leaking. That radiator beam valve module was vented of its ammonia, so it is ready to have its suspect flex hoses removed. They will be replaced on a future spacewalk. Arnold will also be riding at the end of the robotic arm for the removal and replacement of a camera assembly out on the Port 1 truss of the International Space Station later in today's spacewalk activities. This is Mission Control Houston. We're about to regain our downlink video, and there it is. As you take a look at the backpack of Drew Feustel, that is the simplified aid for EVA rescue jet-powered backpack that Feustel has donned with the assistance of Norishige Kanai and Scott Tingle, who is inside the crew lock section of Quest in the blue shirt that you see there. Feustel is about to be moved into the crew lock section. He'll be followed by Ricky Arnold, who will have his safer unit, as it is called, mounted on the back of his extravehicular mobility unit. He'll join Feustel inside the crew lock section of Quest, as we're about 19 minutes away from the point at which the go for depress would be passed along to the crew from the flight control team here in Mission Control. That'll be after the hatch is closed and the crew has maneuvered
Houston Airlock on 1. Thank you, Leslie. We have both EV crew members in EMU's green light on.
Copy, and that's a good config.
Once we have both jumpers removed, he's going to stow them on his bag configuration on the outside and prepare for the next task of the camera group. EV1 is going to go out to that same area EV2 is at, so he's going to go out to the port side of the truss where camera port 8 is zenith. He's going to prepare and deploy the bag with the new camera group and get ready for EV1 to translate over from the RBVM. You see here it's a short transfer over from the RBVM jumpers to the camera group. This is a camera port 8. The pan and tilt has stopped working, so we're going to pan and tilt that unit down into the stowed location before we remove it. So both crew will work together to get this camera group out. The first thing is moving it to the stowed location so we can remove it. After that, we'll lock the pan and tilt unit and disconnect the electrical cable. Once that's disconnected, then we'll position ourselves to remove the camera. We have an HD camera and a standard camera. We're going to reuse this high definition camera. So we'll remove that prior to removing the camera group. Once that's removed, then we'll remove the camera group, which is the camera and the light. And he'll hand it down to EV1, who will hand up the new camera group. While EV2 is working on the new camera group to get it installed, EV1 will be packing up the failed unit and taking it back to the airlock. As EV1's completing that translation back to the airlock and getting a get-ahead back there, EV2 is going to continue with the camera install. We'll start with the standard camera and the light install. Once we're complete with that, then we'll work on the HD camera, putting the HD camera that we removed previously back on to the camera group. After installing the HD camera, we'll reconnect the electricals to get it all powered up, and we'll be complete with this task. EV1's back. We're going to transfer bags. If we have enough time, we're going to go after a couple of get-aheads while the crew is on the arm. EV1 is going to take back the jumper bag and put it in the airlock. For this video, we have not shown the get-ahead, so EV2 is going to get off the arm there at the port truss, and EV1 is going to go get ready for the next EVA. We're going to remove a jumper from behind the MLI on the starboard truss and take that down to the PFCS. For the next EVA, the PFCS relocate. They're going to be swapping out 2 pump flow control sub-assemblies. So we're going to help them and get a little bit ahead by removing this jumper and deploying it down at the PFCS on the port side of the lab. And then he's going to be complete for the day. EV2 is going to take the APFR out of the arm that he's been riding and take it to that same location again, trying to set the next EVA up to get a little bit ahead when they go out the door so they don't have to move these items down to the work area. So he's going to take it to the port side of the lab where he's going to deploy that down at the PFCS locations. Once we get that installed, then both crew are going to return to the airlock and come inside.
And the left.
I'm a copy.
So the animation you just saw, Grant Slusser, our lead EVA or spacewalk officer for today's activities, running through all of the work that lies ahead for Drew Feustel and Ricky Arnold. As you just heard a moment ago, Norishige Kanai of the Japan Aerospace Exploration Agency in the field of view, reporting back to Mission Control that Scott Tingle has closed the hatch that you see there, separating now the 2 spacewalkers who are behind that hatchway in the crew lock section of Quest from Kanai and Tingle, who are in the equipment lock section of Quest. A short time from now, the green light will be given for the start of the depressurization of the crew lock section that will set the stage for the start of today's spacewalk, likely to begin in the neighborhood of about 8:15 a.m. Central Time. While we have a moment or two, let's take a couple of additional questions submitted on social media for us today. at the hashtag of Ask NASA. Miss Spillers writes in and says, what happens if an astronaut runs out of air during a spacewalk? That would be highly unlikely. We monitor the oxygen levels and other consumable levels in the two crew members' spacesuits throughout the crew's time outside of the void of space. In the unlikely event a suit problem would occur and oxygen would be depleted sooner than later, we would direct the crew member back into the safety of the crew lock section of Quest where they are at the moment. And Sai Karthik asks, how do you take care of the light and ultraviolet rays from the sun from damaging the spacewalkers' eyes? Their helmets are specially designed to protect them from the harmful effect of ultraviolet rays from the sun through their visors. the outer thermal cover to the Quest airlock, then open the hatch itself, and on approval of mission control here, will place their suits on internal battery power that will mark the official start of today's. Good view of Norishige Kanai of the Japan Aerospace Exploration Agency and Scott Tingle right at the hatchway. Those two will be returning to Earth on June 3rd in their Soyuz MS-07 spacecraft, along with Russian cosmonaut Anton Shkaplerov for a landing in south-central Kazakhstan.
Your valve as loud as mine?
Yeah.
We have gone into a handover between satellites on the tracking and data relay satellite system. We'll be regaining our downlink TV and voice communication capability with the crew on board the International Space Station a short time from now. Again, the International Space Station is currently flying near the border of China and Mongolia at an altitude of 254 statute miles. Here in the flight control room, the Orbit 2 team of flight controllers led by Flight Director Tony Sakachi, right there at the Flight Director console in the white shirt, second from the right at the bottom of your screen. He is presiding over today's spacewalk. A pair of space flight communicators are on duty to his right, Leslie Ringo, who is maintaining communications with the crew up until the point that they're ready to go out the door. And on the far left of your screen is Japanese astronaut Aki Hoshide, who will be the spacewalk communicator talking directly to Feustel and Arnold during the course of today's activities for them outside in the void of space.
Actually hear the airflow out of the valve. Yeah. Didn't notice that before.
Just to reset some of the statistics, this will be the 209th spacewalk in support of space station assembly, maintenance, and upgrades, the 7th in Drew Feustel's career, the 3rd for Ricky Arnold. Once outside, and they activate their helmet cameras that will provide us an up-close and personal view of their tasks as they see them. Drew Feustel's helmet camera will be marked by the number 17 in the lower right-hand corner of your screen. Ricky Arnold's helmet camera will bear the number 18.
Pressure 350 for 259er.
Depressurization continuing, no issues. We're heading down to 5 pounds of pressure per square inch, where we'll take a pause to allow the flight control team here to conduct systems checks and for the crew to conduct communications checks with mission control before the depressurization resumes down to vacuum.
Stable. 2. Three. I'm showing 5.1, 4.0, 4.8 is the suit. Okay.
Okay, Richie, please close the best pump isolation valve.
It is closed.
Copy, close. Step 5, the dig check on the display, please. Dig check, question mark, and yes, and follow the direction.
And we have paused the depressurization of the crew lock for a short period of time at 5 pounds of pressure per square inch, per the flight rules, taking systems and communications checks before the depressurization resumes down to vacuum.
Check complete for 2.
Copy 2.
Check complete for EV1.
EV1 and both EV1, EV2. Check auto actuator EVA.
Work. And work.
Both suits in good shape. Reported back to mission control.
I think so. Okay, EV1 O2 actuator EVA. And EV2 actuator EVA.
Copy 1 and 2. Okay, EV2, deflex pump manual